Welcome back, IB Pre-Calculus, to your next video lesson in Unit 8. So in this video, we will be building on what you did last time with normal distributions, and we will be looking at some applications. So hopefully you have some recollection and you recall the standard normal curve. You have some understanding of z-scores and how you find z-scores, right, to standardize the normal curve, as well as p-values, right? And you even did an extension where you made a connection of where you're going to be going with this in calculus, right? And the area under the curve, as well as how you can use the calculator and some of the calculator functions to figure out the p-value, right? As well as if you're given the p-value, as well as you're given the probability or the area under the curve, actually finding the z-score and finding the score. So to start off this video, we're going to do some review of what you got last time and then dive into some applications together. So from last time, you and two of your friends, so 3 of you, are taking a test. You're each in different sections and you want to determine who performed the best relative to their class. Use the info below to find this out. So I don't know which one is you can kind of decide, but as you can tell, they all have a different mean and a different standard deviation. Therefore, we need to figure out, or we want to figure out, the z-score, right? So the z-score is how many standard deviations above or below the mean, right? We're assuming that the mean, or mu, is 0 and the standard deviation is 1. How far above or below the mean you are, but these all have a different mean. So we want to translate it into 0 to kind of figure out what this is. And that's where the z-score is going to help us. So if you recall, to find the z-score, I'm going to take the data point minus the mean divided by the standard deviation. And that's going to give me my z-score, right? That's going to normalize this. So 42 minus 50 divided by 11, I get, let's get our calculators, 42 minus 50 divided by 11, I get about negative 0.73. Okay, I'm going to draw a nice normal curve down here so we can kind of compare it. So there's my mean of 0, negative 0.73, so I'm not quite 1 standard deviation below, right? Like this would be, I'll say 1. And so I'm about right here. I'll call this student A. Okay, let's see what's going on with student B. They got a 73 when the mean or the average was a 79. So they're still below, and the standard deviation was 8. So 73 minus 79, the difference between what they scored and the mean divided by the standard deviation, gives me negative 0.75. Right? So they, relative to their class, they didn't perform as well as the student. It's close. They didn't perform quite as well. So it gets a little bit closer here. So like this is student B. What about student C? They got a 243 and the average was a 260. So 243, the difference between what they scored and the average, still below, farther below than any of these other ones. And then the standard deviation is 24, right? So 243 divided by, minus 260. Oh my goodness. Divided by 24. I get about negative 7.71. Right? So they're all pretty close together, but to actually answer this question of who performed the best relative to their class, well, student C, maybe that's you. Maybe you're going to claim that as you, right? So student C performed best relative to their class. They're the closest to the mean. right? They're only negative 0.71. They're only 0.71 standard deviations below the mean, whereas this one's a little bit more, It's really close, right? But to directly answer this, student C would have performed the best, right? And so what we're doing here is using z-scores so that we're comparing them all to have the same mean and the same standard deviation. Right now it's not comparable until I take a look at these z-scores. The other thing that we looked at, and this looks similar to last time, I have some different problems up here and I want to show you the calculator, is we think of probability or p-values as the area under the normal distribution. To find the probabilities, we can use our calculator. And as you talked about last time, or as you heard about last time, this 0, 1, the mean and the standard deviation, your calculator is assuming that that's true, right? So we're assuming that these are normalized. So assume Z is normally distributed, sketch the normal distribution and shade the probability, then compute the probability using a calculator. So let's go ahead and sketch and label it and shade it, and then I'll pull up the calculator and we can go through that. So I'm going to sketch a normal distribution, right? This is saying the probability is between negative 1.2 and 0.5. Well, I know that the mean is 0, so I'll label it. So this is negative 1.2 to oh, that looks a little off, to 0.5, and I would shade the part between it, right? It's between those. So when I'm going into the calculator, this is going to be your lower bound, and this is going to be your upper bound. The probability is greater than 1.2. That's a horrific normal curve. It's okay, right? So that's 1 standard deviation above the mean. That's 2. So I'm about here. 1.2 greater than, I'm shading this part. Well, I want to remember that the lower bound is going to be that 1.2, and the upper bound, I'm just going to be extreme here. I'll go with like 10,000, right? Something way up there. For D, oh goodness, what is down here? 0, negative 2.3. So there's negative 1, negative 2, negative 2.3. And I'm shading less than it. So this is like a little bit, and it's not going to be a ton. And so I want to remember that my lower bound, I'm going to be extreme, is like negative 10,000, and the upper bound will be that negative 2.3. Now this last one, you saw something like this in the last video, in the last PowerPoint, but it actually had the absolute value was greater than 1.3. And now I'm saying less than, 1.32. And we saw that if the absolute value is greater than 1.32, it's the two tails. Right here, I've now switched it, and I'm going to do less than. So when I'm going ahead and sketching the normal curve, and I focus in on negative 1.32 and 1.32, I want it to be less than. So I'm actually looking at the part that's between them in this case, right? These were the two tails. This is the parts that are between. So in this case, my lower bound would be negative 1.32, and my upper bound would be 1.32. So let's go ahead and take a look at the calculator. So to just run through these, second vars is distribution. I'm going to go down to number 2, normal CDF. And this is how mine asks it, but yours, you might have it where you're just putting commas between it. And as a reminder, like, you don't need to type the 0, 1. You don't need to worry about that, right? Where that's, your calculator is going to default to that. It's going to assume that. So I've got negative 1.2, and my upper is 0.5, paste, don't touch those. And I've got this, right? So like almost 50% falls between those two. Let's let me write. So the probability would be 0. I keep forgetting it, 576. Right here. Second vars, let's do it again. Go down to 2, 1.2, and then something extreme. 0. And this makes sense, right? Like, think about it. After you get it, okay, does it make sense for what I shaded? Yeah, right? 0.115. So like almost 12%, right? Second distribution, I'm on to the third one. It's less than, so negative 10,000 here to negative 2.3. This should be a very small amount. Right? This should be a really small probability. Yep, 0.012. And then finally, the way that we set this up, second vars to go down to 2 again, my lower bound is negative 1.32. My upper is 1.32. And I'm looking for the part in between them. So that's about 81.3%, 0.813. Okay. So then you looked at this going the other way, right? So computing the z-scores from the p-value. So given the probability, find where does this fall on the normal distribution, right? And as with many operations that you've done, when you go backwards, we're using the inverse, right? So it's the inverse norm of the probability. And again, you don't need to worry about this, right? What you do need to make sure that you're aware of is that this ends up being a left tail probability, right? The probability is going to be like when you're given it, the way I might be drawing it or shading it is if this is 0.53, when I'm doing it, my calculator is going to calculate where 0.53 is that z score and less. Right, so just be mindful of that and pay attention when you're doing this to, is it positive or is it negative? So we're going to go ahead and sketch these. I'm going to do it the same process that I just did in the last one. Let's sketch it and label it, and then let's go ahead into the calculator. So this is 0. I don't know what z sub 0 is. That's my goal to find. But I know that I want, so z is less than this, and that's 0.53. So my z score will be above 0, right? It's above the mean. Right? This would be 50%, so it's got to be a little more. And I want to figure out, well, what is this z? And remember, it's less than, so I'm going to the left there. I'm shading everything over here. And I'm finding this area. So this area in here, and I'll label it. That's interesting. Would be 0.53. Okay, so I know that I want my z-score to be positive here. I'm going to make a note of that. Over here, be careful. Pay attention to the fact that it's greater than. Okay, so 0.42 is greater than. So I've got 0 as my mean. Well, my z-score, I'm talking about a z-score that's above the mean because less than 50% is above this z-score, right? So I want to pay attention to the fact that whatever my z-score is here, this is the part that is 0.42, right? This is 0.42. It's hard to see, sorry about that. And do be mindful that there's different ways you can approach this, right? Like I could go ahead and here, obviously I'm going to be doing the inverse norm and I need to, I'm just doing 0.53, right? I shouldn't have to do that 0 and 1 because my calculator knows that. Over here, I want to make sure that I'm paying attention to the fact that when I do inverse norm, of 0.42, it's going to produce a negative value for me because it's going to be the reflection of this, right? I'm going to be looking at this over here where this is 0.42. So I want to figure out, no, I want it on the other side. So I could negatize it. The other thing I could do, if I didn't want to have to remember that, is I could look at the other part of the probability distribution, right? And I could look at 0.48. Oh, goodness. Right, 0.48. No, 0.58 was correct. Right, and that would give me, that's the percentage that's below here. That's the area that's under the other side. These, what I can negate this, right? Do the negative version of this one, or I could just go ahead and do this. So let's do it in the calculator. So second vars, I'm going to go down to number 3. And the area for the first one is 0.53. I don't need to touch these. Enter. And oh, I've got the z-score, forgot it, is 0.075. Right? So what we've just figured out is the probability, and you can even check your work with this, that it's less than 0.075 is 0.53. Okay? It should be pretty close to 0. 53%, pretty close. It's not far above 50%. Over here, I'm going to go ahead and do second distribution 3 again. And if I go ahead and I type in 0.42, you're going to get a negative value. Right? I get negative 0.202. So I can remember that, ooh, no, that's over here. I want to look at the other side. So I'm going to have positive 0.202. That's the same thing if I turned into my calculator right now. I went into my calculator in second distribution and I went down to inverse. And instead of doing 0.42, I did 0.58. Oh, wow. I get the positive version of that. So you can also think about it that way as well. So now that we've had a brief review, let's take a look at a few applications, 3 to be specific. In tests conducted on jet pilots, it's been found that blackout thresholds are normally distributed with a mean of 4.7 and a standard deviation of 0.8. Find the probability, right, the area under the curve, of randomly selecting a jet pilot with a blackout threshold that is less than 3.5. Right? So I'm looking at, right now, my mean is 4.7 with a standard deviation of 0.8. Right? I'm trying to figure out, oh, when I'm at 3.5, what is this area? Right? That's really what this question is asking me. I'm going to go ahead and I'm going to actually use the z-score. I'm going to find the z-score so that I can change my mean to be 0 and my standard deviation to be 1. So to find the z-score, I have my data point, 3.5, minus my mean, 4.7, divide it by 0.8. When I do that in my calculator, I get negative 1.5. I'm going to actually go ahead and sketch and label this, draw and shade this, I guess is a better way to say it. Right, so there's negative 1, negative 1.5, and I'm finding this area. Well, I can go into my calculator, normal CDF, my lower bound, something extreme, to negative 1.5. When you do that, negative, I get 0.067 approximately. So what's the probability of randomly selecting a jet pilot with a blackout threshold that is less than 3.5? This, right? Like 6.7%. Not super high. Okay. Number 2, assume the weights of newborn children are normally distributed again with a mean of 116 ounces and a standard deviation of 12. Find the probability of randomly selecting a newborn child who is between these, right? So again, I'm going to go ahead and actually find these z-scores and then sketch and label it, right? So that would be of the lower, and then of the upper, I'm going to have 124 minus 116 over 12, 108 minus 116 divided by 12. It's like negative 2/3. I'm going to leave it like that. And then 124 minus 116 divided by 12, I get 2/3. Right, so this is 0. If this is -1 and 1, I'm not quite there, right? So I'm doing 2/3, negative 2/3, and 2/3. And I want the area between it, right? So I'm going to have normal CDF, and you're going to do this in your calculator, negative 2/3, 2/3. I don't need to worry about the mean and the standard deviation. The mean is 0 because I'm finding the z-scores, and the standard deviation is 1. So I can go ahead to normal CDF, negative 2/3, comma 2/3, enter. And I get, it's almost 50%, right? So what's the probability of selecting a newborn between those? I got 0.495, right? 49.5%. What about 110 to 112? I'm sorry, 122. So 110 minus 116 over 12 is negative 0.5 or negative 1/2. And then the upper is 122 minus 116 over 12, which is 1/2, right? Yeah, 4, 5, 6. So sketch it. 0. Here's, oh goodness, didn't mean to do that. Here's -1 and 1. So negative 0.5 and 0.5. Finding that area. So I've got normal CDF of negative 0.5 to 0.5, which gives me, right, it should be a little bit less than this, less than 50%. Like 38.3%, 0.3829, right? 38.29%. All right, so let's take a look at this last one. Scores on a college entrance exam are normally distributed with a mean of 500 and a standard deviation of 100. If 70% of all examinees pass, find the passing grade. So here, I don't know the score. Okay, I want to show my understanding of what's happening here, and so I do want to show some of the math pieces behind it. So it's normally distributed with a mean of 500 and a standard deviation of 100. If 70%, so I'm gonna sketch a picture to be able to visually see this a little bit better. So 70% of the examinees pass. Okay, so I want to figure out what is the score where 70% of the people are above it, right? So the area under the curve would be 70. So I want to think about it this way. I want this whole thing, I want the area under this curve to be 0.7. Okay? So I'm trying to figure out, like, what is this score? And there's a few different ways I could do this, as was true with the other ones, right? And so I'm just going to do this in a way that I'm going to go ahead and actually find the z-score. And so I'm going to be using the inverse norm, and I'm going to do it of 0.7. I need to remember that this would be left-tailed, so I want to negatize it. I want it to be negative. So I'm going to go ahead and second bars, go down to inverse norm, 0.7, and I'm going to get negative, I'm going to get positive, that looks like theta now. Originally, I'm going to get 0.5244, but I know I want it to be negative. So now I actually have this z-score. So I can go the other way, right? I could use my z-score to figure out what is the data point, right? What is that cutoff? I know the mean and I know the standard deviation, right? And I could solve this. I could multiply by 100 and add 500, and I'm going to get 447.56 approximately, right? So the passing grade would be this. That would be a passing grade. I could technically not find the z-score, and I could think about it more like I could do inverse norm of 0.7 and use this mean. And I could have done this for the other one too. It's just not really demonstrating a high level of understanding. But I would probably want to use the, what's it called? Not the 0.7, right? Because it's going to be left-tailed. I would probably want to use the 0.3. And then go ahead and say, I could actually type in the 500 and 100. Again, this doesn't really demonstrate the same level of understanding of what's happening, but it is good to know that you can do this as well, right? You're just not standardizing it. Like this is, I'm just saying this is the mean and this is the standard deviation, right? Without changing the mean and the standard deviation. You're going to get the same thing. You'll see that. I could also even, and I didn't really round too much, but I could also store this in my calculator if I wanted and recall it, so that I didn't have to round in this situation. And again, to get from here to here, I multiplied by 100 and added, yeah, past tense, added 500, okay? All right, so in this lesson, we reviewed some of the stuff about normal distributions that you got in the last video lesson and looked at some of the calculator keystrokes again, as well as looked at some applications. You guys have a homework assignment on this, and we will be practicing and reviewing and taking any questions we might have about normal distributions when we see you in our next live session. Thanks, everyone. See you all soon.